All right, these are the section 9.1 additional exercises, and looks like there is a typo here. So number one, just go ahead and add a parentheses here. And we want to determine if the relation defines a y as a one-to-one function. So first, is it a function? Check your x values. We have no repeating x values. Good, so each x value is going to a y value, so it's a function. Now we have to see if it's one-to-one. So we check the y values. Do we have any y values that repeat? Well, we already checked the x values. They did not repeat, so they were good. Now we check the y values. And we have no repeating y values. So each y value is coming from exactly one x value. So this is one-to-one. Let's try number two. Actually, let's do this. I'm gonna make up another one. Call this 1b. So determine if this relation defines y as a one-to-one function. Now, you might be tempted to look at the y values and say, hey, each y value comes from exactly one x value. You think, okay, I'm good, right? But remember, it has to be a function. You have to start there. And the problem we have here, this is not a function. I got this -5 is going to two different y values. So this is not a function. And so it's certainly not one-to-one. All right, let's try number two. So I think this is the correspondence. And so each x value goes to exactly one y value. Each y value goes to exactly one x value, so this is one-to-one. And this passes the horizontal line test, so this is one-to-one. All right, let's try number four. Well, this would not be one-to-one because here's a horizontal line that passes through more than one point. So this would be no. It is not one-to-one. Now, sometimes they'll ask you, does this relation have an inverse function? Well, remember, to have an inverse function, to have one-to-one. So it's pretty much the same thing. You still use your horizontal line test. This does have an inverse function, whereas this does not have an inverse function. All right, so given that the function is one-to-one, all right, and we got the domain. The domain here is from -2 to 3, including -2, not including 3, and the range of f is -1 to infinity. State the domain and range of f inverse. Remember, we just switch around the domain and range. So this is going to be the range of f inverse, and this is going to be the domain of f inverse. So I'm looking for this domain. All right, that eliminates A, eliminates B. Let's take a look at C. And it's the range. So it looks like the answer here is C. Okay, let's go and graph the inverse here. And feel free to pause the video, try the problem yourself, and then come back. All right, so again, I'm going to be switching around the x's y coordinates. So this is the point -3, -2. Switching x and y, that would be -2, -3. So that'd be this point's down here. Next point I'm going to be looking at is this 0, 1. Switching around, that's 1, 0. And then the last point we're looking at here is 1, 3. Switching around, that's 3, 1. And let me just kind of write these points down here. So this is what my inverse graph should look like. And we see it doesn't look like this one here, so A won't work. But B does, because notice it goes through those 3 points. So my answer has to be B. All right, let's try number 7. So again, I'm trying to determine what the inverse function looks like. And draw my y equals x line to help me out here. So I have this point 0, 1, that's going to be 1, 0. And let's see, this looks like, I don't know, about -1, a quarter. So if I do quarter, -1, that's probably about down here. And that's getting closer and closer to 0, so this should be getting closer and closer to 0 here. And let's go over here. This looks like about 0.5, 2. So 2, 0.5, so that's about here. So it's kind of going like that. So I got to look for something that matches the green. Again, notice what I did. I kind of looked at some points, switched around the x and y coordinates to help me draw this in. A is not a match. B is. So B looks good.